In our work, a human user teleoperates a ground robot through a remote environment using a haptic device, which provides force feedback to assist the human in safely navigating through their environment collision-free. The proposed force feedback consists of two components. The first is a collision avoidance force, which helps push the robot away from the obstacle, as shown by the blue force vector. The second is an obstacle avoidance force, shown in pink, which pulls the robot toward a safe path generated by our proposed local path planner. These two forces are combined into a single force and fed back to the user. Here we show a simulation of a robot navigating through a 2D environment. A PD controller acts as a virtual pilot to steer the robot from the blue dot to the red X, while the force feedback steers the robot away from the obstacles. Obstacles change color to red when they are within the detection radius of the robot. The paths that the obstacle avoidance force follows are shown in green. Here we show some hardware experiments. The same PD controller steers an NVIDIA JetBot through a motion capture space over Wi-Fi. The animated trajectory is shown in the bottom left. We performed 3 sets of user experiments. In the first case shown here, a human experimenter, whom we can see in the bottom right corner, sits outside the environment and uses a geomagic touch to steer the JetBot without haptic feedback. In the second case, our proposed haptic feedback is provided to the user as they navigate through the same environment. In the final case, the user has no visual feedback and instead relies on the haptic feedback to avoid obstacles while driving to the target position. We can see that the human is able to navigate safely to the goal under the haptic feedback without needing to see the obstacles.